Yeah, as Jim mentioned, I've had the privilege of studying high-performing technology organizations. This is a journey I've been on for 19 years. And so back in 1999, I was the CTO and founder of a company called Tripwire in the Infosec and compliance space. And our goal was always to study these amazing organizations. We called them high performers that had the best project due date performance and development. They had the best operational stability, and they had the best posture, security, and compliance. And so the goal was, how did these amazing organizations make their good to great transformation? And the reason why we wanted to understand that was that we wanted to understand how other organizations could replicate those amazing outcomes. And by the way, that's when I met Allison Miller back in 2001. That's where I met so many people here. I'm just so delighted to be here today. But in that 19-year journey, there were many surprises. But the biggest surprise was how it took me into the middle of the DevOps movement, which I consider myself maybe one of the primary cheerleaders for. But I think it's a genuinely important solution to an even more significant business problem. And I think it touches everything about how we work with software. So in the next 40 minutes, what I want to share with you is what I've learned since 2013. So 2013 is when a book called The Phoenix Project came out, which is a novel about an organization that goes through all these problems, and really it's kind of positioned as a way to help describe the problems that DevOps is designed to solve. And so what I want to share with you are the top 5 learnings of what things I wish I had learned before the Phoenix Project came out. And when I say that DevOps is transformative, just to put this into perspective, I think that the last time that any industry has been disrupted to the extent that DevOps is disrupting our work today was probably manufacturing in the 1980s, when it was revolutionized through the application of lean principles. So you take those same lean principles, apply it to the technology value stream, you end up with the same patterns and practices that allow organizations to do tens, hundreds, or even thousands of deployments per day, while preserving world-class reliability, security, and stability. That's something that we didn't even think possible 10 years ago. So, and I said transformative, it is transformative to operations, as it is to developers, as it is to our business partners, but especially for information security, right? I think more than almost any functional role, information security, it changes how we do work. And when I say that I'm so delighted to be here, it's because that I had the privilege in 2012 of being in Austin, Texas, at the OWASP USA conference, where I got to watch Neil Matadel, Justin Collins, and Alex Smolin present one of the most astonishing presentations I've seen in my entire career, where they were talking about the things they were doing at Twitter to genuinely integrate information security into the entire dev and ops processes, right? In many ways, as a part of a consequence of the 2009 Federal Trade Commission consent decree. So I'm so pleased that all 3 are in the room. So here's number 1 surprise that I certainly wish I had learned before the Phoenix Project came out, was that the business value that DevOps creates is even higher than we thought. So this is based on work that I've been doing with a gentleman named Jez Humble. So he wrote the Continuous Delivery book. We wrote the DevOps Handbook together. Dr. Nicole Forsgren, and for many years with Puppet, we benchmarked over 26,000 organizations. And over the past 4 years, we've been able to identify what does high performance look like and what are the behaviors that cause high performance. So one dimension of performance is throughput and agility. In the 2017 report, so we've done this over 4 years in a row, we found that high performers are doing 46 times more frequent deployments. So think of deployments not only as just code, but to any changes in the environment. And more importantly, they can complete those changes 440 times more quickly. In other words, what is the cycle time as we go from code or changes put into version control? And version control is not just for developers, it is for operations and information security. Anyone who gets into production needs to go through version control, through testing, through deployment, so that customers are actually getting value. High performers can execute the cycle in 1 hour or less, whereas lower performers take orders of magnitude longer, right? Think weeks, months, or quarters. And it's not just about doing more work. We know that high performers get dramatically better outcomes when they deploy. We know that high performers, when they deploy, they're 1/5 as likely to have something bad happen, whether it's a service impairment, a 7 outage, a security breach, or a compliance failure. And bad things happen because Murphy's Law does exist. When bad things happen, high performers can repair those issues 100 times faster. In other words, the mean time to restore service is 100 times faster. So, in the early days of the research, this was shocking, right? Because it gave us decisive evidence that you can be faster and be more reliable at the same time. And in the early years, there was a lot of anxiety when we did the research because we were nervous that we wouldn't see it in that year's study. but now it's so routine. We know with moral certainty that the only way to get these kind of great reliability profiles is to do smaller deployments more frequently. And so over the last 2 years, we looked at other dimensions of quality. We know that high performers, because they're integrating information security objective into everybody's daily work, they're spending 1/2 the amount of time remediating security issues, right? So it's twice. So we can see the effectiveness there, and because they're doing a better job controlling unplanned work, they're able to spend nearly 1/3 more time on planned work, right? So these are planned. This work tends to be more strategic, as opposed to the tactical, maybe even value-destroying work of firefighting. So as a population, we call that IT performance. 3 years ago, we looked at another area, which was organizational performance. And what we found was that high performers were also twice as likely to exceed profitability, market share, and productivity goals. And for years, people have been asking, what if we're a government agency? What if we are a military service or not-for-profit? And so in 2017, for the first time, we had a separate branch in the survey that said, if you're a not-for-profit, we took you down a different path. And what we found was the same multiple of performance. Not-for-profits were twice as likely to achieve organizational and mission goals, regardless of whether it was measured by quality, quantity, customer satisfaction, and so forth, right? So, I think the conclusion is pretty obvious, right, is that if mission achievement requires work from the technology value stream, the work that we do every day, DevOps helps with enablement of those things. Other markers of organizational performance include the fact that high performers, employees are twice as likely to recommend their organizations to their friends and colleagues as a great place to work. That's called the Employee Net Promoter Score. And there's a whole body of literature out there that says that that is highly correlated with revenue growth, profitability, and so forth. And there's this other thing that we found, which was that high performers, for those publicly traded, they had 50% higher market cap growth over 3 years. And I just want to pause for a moment there to say this is in some ways an absurd finding, right? Because essentially what this is suggesting is that how a server admin, how a DBA, a developer, how they do their daily work could impact profitability and maybe even be visible in share price, which I think is kind of stretching believability. But I will be the first to admit that. But if we believe that strategic work is reliant upon the technology value stream, perhaps if those organizations can be 3 orders of magnitude faster than the competition, maybe that will create decisive winners and losers in the marketplace. And that I find to be incredibly believable. So I think it's just a really wonderful finding. There's another metric I want to share with you. And in the DevOps community, this is probably one of our favorite metrics, deploys per day, right? In fact, the seminal presentation about DevOps in 2009 by John Allspaw at Flickr, who went on to Etsy, and his dev compatriot, Paul Hammond at Yahoo. They were shocked the world by saying they were doing 10 deploys a day every day. But what is interesting is, even more interesting, is this relentless increase in number of deployments per day, right? These days, Amazon, in 2015, Ken Exner said, at Amazon, they're doing 130,000 production deployments a day, right? So the question is, what causes this relentless increase in number of deployments per day? And we started to hypothesize that deployments per day maybe is hiding an even more important metric, which is deploys per day per developer. And so we tested this. On the y-axis, you see deploys per day. And on the x-axis is the number of developers. And what we found was that as you increase the number of developers in low performers, deployments per day goes down. In medium performers, as you increase the number of developers, deploys per day remains constant. Whereas in the high performers, as you increase the number of developers, deployment per day goes up linearly. So this is a logarithmic scale, right? That is actually linear growth. And so what makes this so interesting is that so many of us were trained by Frederick Brooks in his book, The Mythical Man Month, right? He actually did explain so much of our common experience that in general, when you double the number of developers, or maybe more specifically, double the number of development teams, in general, you double the code integration effort, you double the testing effort, the securing effort, and you more than double the effort to get value to the customer, right? And I think we've all lived through that at one point in our career. But what this graph shows us is that under certain conditions, with the right architecture, with the right technical practices and the right cultural norms, we can actually scale developer productivity linearly. And that's something you hear the high performers talk about, regardless of whether they are a developer in QA, ops, or information security. And I think this starts to suggest what the opposite of technical debt is. The opposite of technical debt is to what extent can we safely, quickly, reliably achieve all the goals, dreams, and aspirations of the organization that we serve. And maybe just to put this into perspective, one of my favorite statistics was Instagram. When they were acquired by Facebook for $1 billion, that was 10 engineers. Pokemon Go, the fastest property to 1 billion users, was 25 engineers. So I think kind of the goal of DevOps is like, how do you enable taking 25 engineers, put them into any modern business context, and have them do those kind of miraculous things? So, surprise number one was definitely how good DevOps is for the achievement of business outcomes. Surprise number two is DevOps is as good for operations and security as it is for developers. In fact, oh my God, I love the fact that there's so many Facebook people here. So it's 2018, and still my favorite case study of how good is was the Facebook chat launch story that happened in 2008. Right, so some of you may roll your eyes because you're saying, it's 10 years old, right? How relevant can it be today? Some of you might be saying it's a chat server, right, that undergraduates write as part of their computer science curriculums. That's true too, but what you might not know is that chat is actually inherently an order n cubed algorithm. I think even to this day, they would consider chat to be the most ambitious technical undertaking ever done at Facebook still to this day. It took 1 year for them to do with the largest project team. And so what's interesting is like how they use that year. So imagine the chat team being constituted sometime in 2007. And very quickly, this team is starting to create code. And they're checking that code into a shared source code repo. Whatever was in the source code repo at 2 p.m. Pacific time would be silently migrated into the production environment without causing chaos and disruption. And what's interesting is they do it in the middle of the day. Right? Not at 4:59 p.m., not at midnight, right? They're doing it in the middle of the day, so if something goes wrong, they can roll back, or worst case, everyone's in the office to help if needed. So that's certainly interesting, right? As opposed to so many organizations today, they do deployments at midnight on Friday, and they have to work all weekend to get things running, right? So that customers don't notice if something goes wrong on 9 p.m. on Monday morning. So that's one technical practice. A second technical practice is the fact that they were testing in production for nearly a year. So for the vast majority of that year, whenever someone was logging into a Facebook property, there would be some JavaScript code that would run in the client and would send invisible test chat messages, to the servers, in the data center, right, invisible to customers. So why would they do that? It was so they could simulate production-like loads, right, well before the release. And so this is when they have the most amount of freedom to change things, right? If you find performance issues 11 months before the release of the product, right, you have 11 months to change things. You can even change architecture. Whereas if you find performance issues during the middle of the deployment, you have almost no degrees of freedom. So just to share with you why I think that's so interesting to me is that if you had told me 5 years ago that it would be okay for developers to test in production, I would have said, are you insane, right? It's like, I don't know what developers but I can promise you developers don't care about quality, right? If you've seen the things I've seen deployed in production, you would also conclude these things. And yet, I've changed my mind, is that I think to give developers the ability to test in production is an absolute game changer because it gives the fastest feedback of everything, right? Whether it's user visible, user invisible, non-functional requirements, or security. But let's go back to the notion of that daily deployment. Here's how important I think that is. I think the best person who's verbalized this is Nathan Shimmick. He said, as a lifelong ops practitioner, I know that we need these type of DevOps practices to make our work humane. In the course of my career, I've worked on every holiday, on my birthday, on my spouse's birthday, and even on the day my son was born. And so I think many of you might be like me, where you've had friends who have had to do this, or maybe even like me, where you've actually helped create these inhumane work systems that have forced people to live with this for maybe years. And I think we now know that there's a better way. So I think the common objection is that you can only do this for open source hippie companies like Facebook. And I think if that is a valid objection, but you should also know about this case study from CSG. So they're the largest bill printing company in the US. So I think even here in Hawaii, right, if you get a paper bill from Comcast, a Time Warner Cable, a Charter Communications, it comes from one of 2 bill printing plants in the US. They're publicly traded. And their focus of transformation was that bill printing application. In my mind, this is a pathological worst case of what anybody should be doing DevOps on. It runs on over 20 different technology stacks, including on the mainframe. The good parts are written in COBOL. The bad parts are written in assembler with vSAM databases. So vSAM databases are not even relational, right? They're column-oriented databases that you have to index into manually. It runs on over 136,000 Windows clients that run inside of their customers. So they doubled their release frequency from 2 times a year to 4 times a year. But that was predicated on the notion of doing a daily deployment. So that means every day they had a team that spanned dev, QA operations. They would deploy into a UAT environment every day in a UAT environment that was almost architecturally identical to the production environment. So what happened? 1 year later, the incident count when they did a production release went down 90%. The mean time to repair when things went wrong went down by 98%. For me, the most interesting telling indicator is what happened to code deployment lead time. 1 year prior, whenever they did a release, imagine it went from 14 days. So 14 days of what? Imagine a release team trapped in a war room, panicking because things are going wrong, customers complaining, executives coming in saying, are we done yet? To which they would have to respond, no, we're not done yet. We have 14 days more to go, right? 1 year later, the release was technically complete at 1 p.m., right? The Xboxes come out because they're just waiting for formal customer acceptance. So it's great for dev, ops, great for the customers because they can get value in half the time. And my claim is if you can do it for something that looks like this, my claim is that you can do this for anything, that these principles transcend the technology stack that it runs on. So obviously great for operations. So let's go to the reciprocal, some technical practices that affect developers. This is still one of my favorite quotes from Patrick Lightbody. In 2011, he said, we found that when we woke up our developers at 2 a.m., defects got fixed faster than ever. Werner Vogel said it even more succinctly, if you help build it, you must help run it. And so I am aware that jackasses like me, showing off jackass slides like this, is probably mobilizing an entire generation of developers to hate DevOps, right? They will now sabotage any hint of a DevOps initiative because I think what they will say is, we did not become developers to wear a pager, right? Pagers are for ops people, right? The whole reason why ops people became ops people was because, they like pagers, right? And so there's an internal consistency to that logic, but I think the more telling narrative comes from Tim Tischler. For many years, he ran the DevOps initiative at Nike, and he said, as a career-long developer myself, the most satisfying point in my career was when I got to write the code, when I got to test it myself, when I got to push it into production myself, when I could see the happy faces of my customers when it worked, and when I could see their angry shaking fists when it didn't work, and when I could fix it myself. And which I thought was astonishing, and just in and of itself. And he then went on to relate to me that he said, over the past 10 years, our ability to self-test, self-deploy, and God forbid, self-fix has been diminished over time, thanks to things like ITIL, security and compliance, right? And by the way, I came from those communities, right? Thanks to jackasses like me, he said, it's taken almost all the joy out of development work. And what is so interesting and paradoxical to me is that these type of practices of putting developers on page rotation actually allow us to bring joy back to developers, increase their productivity, and get far better reliability outcomes and security outcomes for them. By the way, how am I doing here so far? Am I being too cavalier about this claim? Thumbs up? Is this interesting? And by the way, just to show you that I'm not that gullible, at least initially, in the first year of the State of DevOps report, Jez Hummel and I, we had a bet. We asked who would have better deployment outcomes, developers or ops people, right? And Jez being a dev lover, right, he said it would be developers, right, because they are closest to the work, they understand how the pieces fit together, right? They would have better deployment outcomes. And I argued that ops would, for exactly those same reasons. So we split the population into those where devs deployed versus those where ops deployed, compared the change success rates. And the surprising answer was that they were the same. Right? They're statistically identical. It actually didn't matter who deployed, who pushed the button. What mattered was the presence of version control, automated testing, telemetry, that sense of a win-win relationship between dev and ops, right? Those are what mattered. And if those were present, they had better outcomes. It actually didn't matter who pushed the button, right? So, and thus I was convinced. And it's not just me. There's a growing body of people in the DevOps community, not DevOps in the security. They're saying that security is just as important. Topa Pal, he's the first technical fellow at Capital One, They call it DevOps there, right? And what I love about this is that this, in my mind, is the ideal embodiment of how we integrate security objectives into everyone's daily work. So we have all the preventive controls living in a shared source code repository. So anyone can pull from those and inherit the best known understanding of how to solve a problem, whether it's how to do authentication or do password policies or configuration settings. Alongside automated testing, they're doing things like static code analysis so we can find vulnerabilities before it gets into production. Alongside production monitoring, we're running dynamic testing so we can find out about vulnerabilities before attackers do. And the responsibility is held by developers. It's not security solely responsible for it, it's everybody's job. And I think that's what's so exciting to me about DevOps. It's not just dev versus ops versus security. Increasingly it's dev and ops and security all working together as fellow engineers trying to achieve a common objective. So surprise number one was the business value that DevOps creates. Surprise number two was just how good it is for dev and ops and security. Surprise number three is this. There's a metric that looks very tactical. It's like it looks laughably tactical, and yet I now believe it is the most strategic measure of any technology organization, and it's code deployment lead time. So I mentioned in the DevOps community, we love this metric, deploys per day. But in the lean community, that is obviously not their favorite metric. Their favorite metric is lead time. So they would, in fact, there's this deeply held belief in the manufacturing community in lean that goes back almost 60 years that says lead time is the most accurate predictor of internal quality, external customer satisfaction, and even employee happiness. And we found in our work spanning 26,000 respondents that lead time has this sort of magical predictive capabilities in our work as well. And so in manufacturing, they would probably measure lead time as we start the clock when the customer orders, and we stop the clock when the customer receives what they ordered. Or maybe a plant manager would zoom in a little bit and say, we start the clock when we have raw materials at one end of the plant, and we stop the clock when those finished goods are on the way to the customer. So in our research, we chose to define lead time as it starts when a change is put into version control, as it goes through testing, as it goes through deployment, and so that customers are actually getting value. And I think that might beg the question, why do we start the lead time clock at version control, right? Why don't we start it earlier when dev accepts work to go into implementation, or maybe when an idea is first conceived, right? And those are both valid places to start any sort of lead time measurement. But the point at which changes are put into version control, in our mind, represents a very special place because they divide the technology value stream into two qualitatively different parts of work. So everything to the left of code commit is design and development. So the nature of design and development work is that often we're doing work for the first time, maybe never again to be repeated, right? So think about Facebook chat, right? It took 1 year to do, right? And so the lead times are very variable, right? Because we never get a chance to practice. And I think that's just the nature of design and development work. However, everything to the right of changes being put into version control is testing and operations. I would put security in there as well, or a good chunk of security as well, because we want testing and deployment and a lot of information security to have the exact opposite characteristics. We want them to happen not once a year. We want them to happen all the time. We want it to happen quickly, repeatedly, ideally completely mechanistically, right? The same time, every time. And so code deployment lead time simultaneously predicts the effectiveness of testing and operations, but it also predicts how quickly can we give developers feedback on their work. So if I'm a developer and I make a mistake, or I introduce a vulnerability and I check it into version control, if the first time when I could detect that error is 9 months later during integration testing, or when the security team sends me a PDF file, right, the link between cause and effect has almost vanished, right? In fact, arguably, if someone broke the code, right, it's not me, right? It's probably the 99 other developers who are working on that piece of functionality, right? And so the time to detect, time to fix are exponentially harder. What we want is, in the ideal, is that the instant I introduce that change into version control, that should kick off automated testing. And so I should detect that error within minutes, worst case hours, right? And so that allows me to not only find my error, but it also prevents me from making that same mistake, every day for the next year. And the same thing, I think, holds absolutely for security as well. So code deployment lead time simultaneously predicts effectiveness of testing and operations, and it predicts how quickly can we give feedback to developers on their work. So not only can they learn, right, from mistakes, but also how quickly can they learn from customers. So, all right, how am I doing here so far? Is this interesting? Yeah. So, it looks tactical, and yet I believe it is the most important measure of any technology organization. And it turns out there's actually one question you can ask that predicts all the metrics I've shared with startling accuracy. It predicts the presence of all the technical practices, cultural norms, and architecture, and you can predict all of that with one question. On a scale of 1 to 7, to what degree do I fear doing deployments? Right? And it's like a line. You plot that on the x-axis, you put any other measurement on the y-axis, and if it's 1 is, we have no fear at all, we do them all the time. 7 is we have existential fear of doing deployments, and that's why we do them in our ideal never, right? And so there's a surprising amount of power just in asking that one question that spans dev, QA, operations, and Infosec. So surprise number 1 was the business value that DevOps creates. Surprise number 2, how good it is for DevOps and security. Surprise number 3 is this importance of code deployment lead time. Surprise number 4 is the surprising implications of Conway's Law on everything that we talked about. And so it's my observation that around 2012, any DevOps meetup, conference, someone would be talking about Conway's Law. And I quickly learned that, what Conway's Law is. The most popular paraphrase of it came from Eric S. Raymond, who wrote the book The Cathedral and the Bazaar about the open source movement. He said, if you get four groups working on a compiler, you will get a 4-pass compiler. This is summarizes the work that Dr. Melvin Conway did in 1968, where he showed that there is a stunning link between how teams are divided and the outputs they create. So I could, certainly by the 4th time I had heard this, I could repeat that back to you. But what I could not do is actually tell you how should that inform how we should design or execute our daily work. Until I read the story about the birth and death of Etsy Sprouter. I would love to see if this resonates with you, Mike, from your Etsy experience. But essentially, this is a story about how teams work together to create value. So back in the bad old days of Etsy, in 2008, one of the big problems they looked at, and by the way, in 2008, this was like the bad old days of Etsy, right? This is a day when most people said, if we have to go through another Christmas holiday season like this, we're out of here, right? But even in 2008, they saw this big problem where that in order to ship any sort of functionality to the user, 2 teams had to work together. The devs would work in the front end, and that would be in PHP, where the DBAs would have to work on the back end, and then that was inside of the stored procedures inside of Postgres. And so what they observed was that when you have 2 teams that have to work together, they have to communicate, coordinate, prioritize, sometimes conflict, deconflict, and marshal. And so their goal was to see if they could make these teams be able to work more independently, right? And so that's why they created something called Sprouter. It's short for Stored Procedure Router. And the idea was that the devs and the DBAs could work independently, and they would meet in the middle inside of Sprouter. And as I think it was Ian Malpass said, he said this required a degree of synchronization and coordination that was rarely achieved, to the degree that almost every deployment became a mini outage, right? And so what's so interesting to me about this is that Conway's Law would predict this, right? Is that we went from 2 teams having to work together to 3 teams, right? The amount of communication and coordination goes up, deployment lead times go up, right? And deployment success outcomes go down. So as part of the great rebirth of engineering greatness at Etsy, one of their goals was to kill Sprouter. What they wanted to do was to enable development teams to fully and independently be able to do everything they need to do in the front end. So they used an object relational model so that they could make all the changes inside of PHP. Right? And what they found was that in every place in the Etsy property, where they killed Sprouter, suddenly code deployment lead times went way down and deployment success went way up. Right? And again, Conway's Law would suggest this, right? Because as we went from 3 teams down to 1 team, right? With 1 team, you don't have to communicate and coordinate with anybody. That team is totally self-sufficient and able to get into production, right? And so the lesson to me here is that it's not enough to move boxes around on an org chart. we must also have an architecture that is congruent to that, that enables these teams to work independently. And so what's, in that Etsy example, the numbers are very small, right? The worst case is 3 teams, right? In most modern organizations, it's not 3 teams that have to work together. It's probably like 50 teams, right? It's the DBAs, it's the network engineers, it's the firewall engineers, it's the middleware people, and God forbid, security, change approval, and all these people, right? So it doesn't take much to go wrong, right? For us to have lead times measured in weeks, months, or quarters. And this represents an architectural problem. So one of the big learnings for us in the State of DevOps Report 2017 was the significance of architecture. We found that these things were actually the top predictors of performance. To what degree can teams make large-scale changes to their parts of the system without requiring permission from anybody else? To what degree can they